in this algebra review example, we're going to factor this polynomial completely. So one of the best ways to start is to use, since we have here, we don't have two squares, but we have two square of squares, we could rewrite this in terms of difference of squares. So we can use our difference of squares formula, which is a real quick way to factor these things, since we have two squares of squares. So first thing we need to do is find an expression that will give y to the fourth when it's squared. So something squared equals y to the fourth, right? So this is pretty easy. We know that y squared equals y to the fourth. We also need to find that for k. So what squared equals k to the fourth? So this is just k squared. This allows us to, this first step here allows us to rewrite our expression in terms of the difference of two squares formula. And this formula is extremely useful in this case for us to solve the, to factor the polynomial. So here we can start with so now we can use this difference of squares formula here to factor our polynomial. Instead of writing u here, we're going to write y squared, and instead of writing v, we're going to write k squared. So we're going to substitute these values in. So in this case, our equation above, our original equation, our original polynomial, can be written as y squared squared minus k squared squared. And now it's in the form that we want, because we have u squared minus v squared. So now we can easily factor this out into these two components, right? If we remember that here we've substituted y squared for u and v was k squared, right? So all we're doing is substituting these in here. So next step is we need to continue on factoring, right? So we've rewritten this, and now we're going to take advantage of the right-hand side of this equation. So here we're going to rewrite this as u minus v times u plus v. So here we said u was y squared minus v, which was k squared, times u, which is y squared again, plus k squared v. Right? So now we've factored it for the first time. We've factored this down, right? And immediately something comes to my eye, and that's the fact that we have another difference of squares. We again have y squared minus k squared. So I'm not sure about this side over here, but we can definitely use our difference of square formula again on this side. So in this case, we're going to have u is y and v is just k, right? So I'm going to leave the right-hand side here alone, and we're going to factor this left-hand side using our original formula here. So what we will have is y minus k times y plus k times y squared plus k squared. Right? And so at this stage, we've done quite a bit of factoring, right? our difference of square formula was used twice. So we used the difference of the two squares twice to factor out, and we came up with a completely factored solution.